Thousands of factories experience conveyor jams every day. Most people think the problem is the stack box. It isn't. The real problem is that the entire system has lost the ability to move material. A conveyor jam occurs when products can no longer move through the system as intended. The conveyor may still be running, but material flow has stopped. Engineers don't just ask if a machine has stopped, we ask why. Is the package oversized? Did the packaging get damaged? Was the spacing miscalculated? Did the diverter fail? Or is there a mechanical obstruction blocking the path? We don't assume every jam has the same cause. We investigate the failure mode to ensure it never happens again. A single blocked package rarely stays as one blocked package. A single obstruction quickly triggers a cascade, turning a minor error into a system-wide bottleneck. The conveyor doesn't just stop, it loses its flow. And for an automated system, loss of flow is exactly where efficiency and safety begins to fail. Stopping the conveyor prevents further damage, but it doesn't solve the problem. The system still doesn't know what caused the jam, where it occurred, nor whether it's safe to restart. Engineering isn't about stopping machines. It's about understanding why they stopped. Modern automation systems continuously observe what's happening inside the machine. They use sensors, timing, and machine states to determine when something has gone wrong. Those ideas will become the foundation of everything we build in this series. We've identified the problem. In the next video, we'll design the machine states engineers use to manage conveyor systems safely and predictably.